Okay, so now we can talk about 7.1 antiderivatives. So far this semester, we've been talking about derivatives, derivatives, derivatives. Now let's undo everything that we've been doing. So if f prime of x is equal to capital F prime of x is equal to little f of x, then that means that capital F of x is the antiderivative of f of x. So now we're going to be given the derivatives and we're going to have to find what original function did they come from in order to get to that. So we have two types of antiderivatives. We have definite and indefinite. So we're going to start by talking about definite integrals here. So if capital F prime of x is equal to little f of x, then if we integrate, that's what that elongated s is, that means integrate, little f of x dx, then that's going to give us capital F of x plus c. We have to put this plus c on here because if you think about it, the derivative of a constant is 0. So in order to get that constant back, we have to have an identifier somewhere that said, hey, there's some other numbers out here, possibly some other numbers. So we're just going to throw this generic c inside there. So for example, the integral of 2x dx would be equal to x squared plus c and everything. And the way we get x squared is by the next line here, our power rule. So the integral of any x raised to any power n there, we're going to add 1 to our exponent, so we get x to the n plus 1. Then we're going to divide by that new exponent, n plus 1, and then we're going to put our plus c. The only case that this is not true for is when n is equal to -1. Because when you add 1 to -1, you get 0. You can't divide by 0. So a few rules before we dig into this further. If we have a constant k, so the integral of any constant k dx is equal to k times x plus c, where k is any real number. Sum or difference. Just like we took the derivative of a sum or difference with each individual term we took its derivative, we're going to undo it in the same way. It means we're going to integrate. So if we have the integral of k times f of x dx is equal to k times the integral of little f of x dx gives us k times capital F of x plus c. We can also have the integral of f of x plus or minus g of x dx would be equal to the integral of f of x dx plus or minus the integral of g of x dx. Some exponential rules here. The integral of e to the x dx is equal to e to the x plus c. The integral of e to the a of x dx is equal to e to the a to the x divided by a plus c. When we took the derivative of e to the x, we took the derivative of the exponent, we multiplied in front. Now we're going to take the derivative of the exponent and divide to undo that. The integral of a to the x dx is equal to a to the x divided by natural log of a plus c. The integral of a raised to the kx dx is equal to a raised to the kx divided by k times the natural log of a plus c, where k is not equal to 0. In all these cases, when we're dividing through by those numbers, we cannot allow those numbers to be 0 that we're dividing by, because then we would have division by 0. Now, a special case rule. The integral of x to the -1 dx is equal to 1 over x dx. If we integrate this, we cannot use the power rule because n cannot equal -1. So with that, anytime we see the integral of 1 over x dx or integral of x to the -1 dx, this is going to become the natural log of the absolute value of x plus c. So let's look to see what's going on with all of these now that we have all these rules. So the integral of x to the 7th dx. So this is our standard power rule. What we're going to do, we're going to add 1 to the exponent, divide through by the new exponent, and put plus c. So this would be our answer here. For the second one over here, this would be the integral of x to the negative 6 dx plus the integral of 3 dx if we wrote it out like this. You don't have to write it out like this. If you just want to perform the operation, do it. So we add 1 to our exponent. We divide through by the new exponent. We have a constant, so that's going to be 3 times x plus c. So this would be our answer here. If we were to look at this next one here, x to the 6 over 5 plus 2x to the 3 halves. So same thing. We're going to add 1 to our exponent. So we're going to get 11 over 5. We're going to divide through by 11 over 5. Same thing here. 2x to the 3 halves. We're going to add 1 to it. So that's going to be 5 halves. We're going to divide by 5 halves. We're going to put plus c. So we're going to have 5x to the 11 over 5 divided by 11 plus 4x to the 5 halves over 5 plus c. So this would be our answer to this one in fully simplified form. Now, one thing to keep in mind, in general, we do not have a rule for finding derivatives and antiderivatives of products or quotients. So we need to rewrite this as the integral of 5x to the negative 2 minus 4x to the negative 1/2 dx. Then add 1 to the exponent, divide by the new exponent in each case. So we end up with minus 5 over x minus 8x to the 1/2 plus c. I prefer not to have negative exponents if possible. If they gave it to us with not having negative exponents, give it back in the same way. So just like I said, with quotients, we don't have anything. With products, we don't have anything. So really what we have here, integral of x to the 4th times x to the 1/2 dx, which is the integral of x to the 4 plus 1/2, which is x to the 9 halves dx. So x to the 11 halves divided by 11 halves plus c, which gives us 2 over 11 x to the 11 halves plus c as our answer here. We don't have any rules for stuff raised to a power in general. So we need to FOIL this out. So this becomes the integral of x squared plus 2x plus 1 dx. So in other words, FOIL x plus 1 times x plus 1. We can integrate each term. We get x cubed over 3 plus 2x squared over 2 plus x plus c. So our answer is x cubed over 3 plus x squared plus x plus c as our answer here. So we just have different types, different ways of kind of thinking about things and everything. So the antiderivative of 4x is 4x squared over 2 minus, now this x to the negative 1. Remember, it's a special case, so that becomes our natural log of absolute value of x plus c. So we have 2x squared minus 7 natural log absolute value of x plus c as our answer here. Again, we don't have division rules, so we need to divide this into each term. So this becomes the integral of x squared plus 2 over x dx. We integrate this to get x cubed over 3 plus 2 times the natural log of the absolute value of x plus c as our answer here. So because remember 2 over x is the same as 2 times 1 over x, and the antiderivative of 1 over x is just natural log absolute value of x. If we have 9e to the x plus 5 over x dx, the antiderivative of e to the x is e to the x. Antiderivative of 5 over x is 5 natural log absolute value of x plus c, and that would be our answer there. For this one right here, we want to divide into each one of these. So this becomes the integral of 2 times y to the negative 1/2 minus 3y dy. So 2y to the 1/2 divided by 1/2 minus 3y squared over 2 plus c, or 4y to the 1/2 minus 3 over 2y squared plus c as our final answer here. So we can see different ways of doing it. We just got to kind of see that normally if we have a division, think about dividing into it. If you've got a product, go ahead and multiply that out. Now, for some applications of this, we could have applications which in turn allow us to solve for that c. So what we're doing here is it's saying find f of x if we know f prime of x. So really what we're saying is what is the integral of the square root of x dx? Well, that's the integral of x to the 1/2 dx, which is equal to x to the 3/2 divided by 3/2 plus c, which is 2/3 x to the 3/2 plus c. Now, the only other thing they give us this f of 9 equals 20. So in other words, this is f of x right here. So f of 9 is equal to 2/3 times 9 to the 3/2 plus c. This needs to equal 20. So in other words, this gives us a way to solve for 20, or solve for c, sorry. So this is 2/3 times 9 to the 3/2 is equal to 27. Because the square root of 9 is 3. 3 cubed is 27. Plus c is equal to 20. 27 divided by 3 is 9, times 2 is 18, plus c equals 20, which means c is 2. So really, what we have here is that f of x is equal to 2/3 x to the 3/2 plus 2 would be our answer. Because we needed to solve all the way for c inside of this problem. So we're told, suppose a velocity function is v of t equals 3t squared. Find the position function s of t if s of 0 is equal to 7. So this is more of an engineering application than a business application here. Velocity is the first derivative. So in other words, what we're saying here is that v of t is really s prime of t. So if we integrate 3t squared dt, we get 3t cubed over 3 plus c, or t cubed plus c. But then we're told s of 0 is equal to 7. So s of 0 is equal to 0 cubed plus c must equal 7. So c equals 7. So our function s of t is equal to t cubed plus 7 as our final answer here. So for our last example here, it says the slope of the tangent line to a curve is given by the function f prime of x is equal to 6x squared minus 4x plus 3. If the point 0, 1 is on the curve, find the equation of the curve. So we integrate 6x squared minus 4x plus 3 dx. So 6x cubed over 3 minus 4x squared over 2 plus 3x plus c. Now we need to plug in 0. Well, actually, we could simplify this first. 2x cubed minus 2x squared plus 3x plus c is equal to our f of x. So f of 0 is 2 times 0 cubed minus 2 times 0 squared plus 3 times 0 plus c must equal 1, means c equals 1. So that means our f of x is really 2x cubed minus 2x squared plus 3x plus 1 would be our final answer here.